Now we have next topic is called lathe cutting tools and coolant. So the lathe cutting tool आपण त्याची बी theory आहे. तर कसला tool लावला we can cut the metal. आता drill for the drill कसं तुम्ही हे होता है point angle होता है. For cutting point angle similar way for the lathe cutting tool also there are lathe angle cutting angles. The angle maintain करता है. well ते cutting करता है. Otherwise it will not cut. So what are these lathe cutting tools? कितने basic cutting tools are and what type of coolant you have to apply on the turning of it? Drilling करना उधर वाला है तुम्हें. We are putting coolant now. Water for the coolant. Actually, water we should not use. There is some coolant standard coolant that is not available right now. It will come. I'll show you. The soluble oil it's a mixture of water and soluble oil. The white color is the mixed that you have to apply on the machining job. Drilling capacity. After when you're going to apply water, it will just start rusting. Red if you put it coolant, it will not get rusted. That you have to apply. What is that coolant? What should be the ratio of the mixture of soluble to the water? Very question very important. So lathe cutting tools and comparison. We have types of lathe tools, cutting tools, principal element of metal machining, grinding of tools, solid and tip tools, carbide throwaway tip tools, and comparison of high speed and carbide tools. So these are the all different types of cutting tools used in the lathe machine operation. So types of the lathe tool. You can see the different shape, V shape, single point, and parting tool. This is a boring tool like right hand, left hand. These are different types of cutting. First is types of the lathe tool. Cutting tool used in the lathe operation. Single point cutting tool. Single point cutting tool means having only one cutting edge at the end. These are the single point cutting tool and multi-point cutting tool that are drill points. Classification of single point cutting tools according to the direction of feed, right hand tools, left hand tools. Right hand tools is a feed in cutting the metal from the right to left, cutting edge on the left side. Left hand tool feed in the cutting the metal from the left to right. The cutting edge on the right side. The classification according to the purpose. See, this is the way. Parting cuts, 60-degree threading. This is threading V tool. Workforce. Based on the operation like facing, parting, etc. Classification according to the method of manufacturing. There are some cutting tools are manufactured as per the manufacture process. For example, tip tool means only the cutting point that having the cutting tip. It is braze to the solid blend with the help of brazing, and that cutting tip may be of tungsten carbon, very costly. It cannot produce full cutting tool. Only cutting tip only we have to produce, and we can braze it and fix it on the blend. Then you can use it. So this is the way. Forge or solid tool or tip tool. These are the tip tool. This is solid tool. This is a tip tool. Tip tool only tip cutting tip to का brazing केला असतो. Okay, solid blade it's a full. Cutting tools.
Tool angle. In this video, we will discuss about the tool angle.
What is the tool angle? First example of pencil and knife is given.
No clearance. Without any angle, the knife slides over the pencil.
Correct? Straight double cut जाता ना. Where to give some angle?
Clearance. With a certain angle, knife cuts the pencil. Clearance angle.
Tool act like a wedge to the turn. See, tool act like a wedge during the turning. The wedge shape cutting edge penetrates into the work and removes the metal. The grinding the tool cutting edge to a wedge shape. So cutting tool geometry. आता solid the tool apple, it has to be turned in such a way it has to maintain this angle. कळलं का? Otherwise, there is no use of turning. Turning जातच नाही. We have to get the clearance angles in cutting angle. Clearance angle मिळालं तर त्याचा deep जातला cut. See, the standard terminology is shown in the figure. Before go to this, we just saw this video.
Cutting tool geometry. In this video, we will discuss about the cutting tool geometry. Most important angles in tool geometry are break angles and clearance angles. Some of the important tool geometry are shank, face, side rack angle, end cutting edge angle, nose radius, end relief angle, back rack angle, side cutting edge angle, side relief angle.
Here the rake angle is very important. Point angle. For cutting tool geometry depends mainly on the properties of the tool materials and the work material. Cutting tool must possess a shape that is suited to the machining operation. Side of the tool is generally square or rectangular in the cross. A single point cutting tool, the most important angles are the rake angles and the clearance angle. These are very important angles, rake angle. You have to maintain this both angle. Then only the cutting will take place. Rake means it is defined as the slope given to the tool. Rake means it's a defined. It is a defined as the slope given to the tool. So the slope is given to the tool. No, this is a called rake. This is a back rake, side rake. So from here to there, some back incline is given. It is defined as a slope given to the tools. Rake angles are provided for the following function: allow chip flow in one direction, reduce the required cutting force, provide keenness to the cutting edge, and improve the surface finish. This tool geometry is very important. If this tool geometry is not matching, your turning will not done. Okay. बरोबर. विराज ते माते आदोला त्याचा तू घेणार युनिफॉर्म ना जॅकेट असताना. This is a rake. Angles are provided for the following function: allow chip flow in one direction, reduce the required cutting force, provide keenness to the cutting edge, and improve the surface finish. This is a front rake. It is given on the front portion of the tool. Front rake avoided. This is given on the front portion of the tools. Vastu. Side rake avoid. This is the side rake. From here to here, the side rake is given. That is side raking. When tools removes metal from its cutting edge, it influences the machine. This making this cutting point tool geometry very difficult. एक दिवस आम्ही grinding tool आमच्या जाऊन you forget even if I try myself also not able to do it. But the angles are available, we can manage it. How to cut? Accordingly, we have to manage. So to grind that tool is very difficult because it takes very long time also. Time consuming as well, you require the good skill. Good skill that is sharp angle. But anyway, we have that. We have to maintain that angle, and we can try to cut it. True rake, the resultant slope of the combined front and side rake provides on the tool. Rake or slope of the face generally may be positive, 0 or negative. Positive rake faces the tool slope away from the cutting edge and slant towards the back or side of the tool. Most tools have the positive rake angles. 0 rake face of the tool has no slope and is in the same plane with the upper surface of the shank. Clearance relief angle, the face of the tool slopes away from the cutting edge and slant upward towards the back or side of the tool. These are the slopes down towards the from the cutting edge. Front clearance angle. It prevents the front from front flung rubbing against the work. Angle alla ಈ front face upon it will get rubbed to the work. Like Java point has to touch this front clearance angle is maintained. Opposite slope over rasa it has removed in slope direction. I like the vector. This angle is also down. This and this. If you maintain this both angle, this cutting single point will expose. And once this point is exposed, it will remove the chip from the job. With theory, you can't do the practical later. But purpose best grind, I don't lie and start turning, it will not work. Side clearance. This is the side clearance. You have to maintain the angle, cutting to be perfect. It prevents the side of the tool from rubbing against the work when longitudinal feed is applied. This prevents the side of the tool from the rubbing against the work when longitudinal feed is longitudinal lengthwise tool applied to the so watch side angles avoid the to the job. It varies depending on the feed and increase in the feed. Nose radius is the junction of the side and end cutting edges, a slightly curved at the junction called nose radius. Note angle is the angle between the side cutting edge and end cutting edge. Cutting edge angles. There are two cutting edge angles, namely side cutting edge angle and end cutting edge angle. Side cutting edge angle, it is the angle given side cutting edge between the edge and axis of the tools. End cutting edge angles, it is the angle between face and the surface of the tool. Lip angle, it is also called a cutting angle. It is the angle between the face and the end surface of the tool. Lathe tool construction, tool angles, which is geometry circle understood the circle diagram. Readymade available, you can do the easily lathe up. But cannot top of the angle to class side clearance angle, front clearance angle, front rake angle. Now lathe cutting, different types of lathe cutting tools are distinguished by the shape of the cutting edge and operation which they have to perform. Some of the lathe cutting tools are listed here. आता just operation are तसे lathe tool असेल, right? Based on the lathe operation, cutting tools are available. First one is facing tool, making knife face tool. Third is roughing tool, round nose finishing tool, parting of tool, boring tool, internal recess tool, and internal threading tool. So all this operation having a different cutting tool. First is main cutting edge. This is a turning operation, starting turning tool, wide nose square turning tools. So this is a boring tool, knife, offset knife tool, crank turning tool, round nose finishing tool. See, round nose finishing. Secondary cutting edge and internal recessing tool. Cutting tool materials. After cutting tool, now we should know what are the cutting tool materials. This is little beta cutting tool material on the set. For the lathe machine cutting tool having a special material. We have hard and stronger than the material being cut. Tough to resist a shock load. Resistance to abrasion, thus contributing to long tool life. Cutting tool materials should possess the following qualities: cold hardness, red hardness, toughness. Cold hardness means that it is the amount of hardness possessed by metal at a normal temperature. Hardness is the property by which it can be cut, stretched over metal. other metal. Hardness is the property of metal which can cut and scratch the other metal. When hardness increase, brittleness also increase, and metal which has to be much cold hardness is not suitable for the manufacture of cutting tool. Red hardness, it is the ability of tool material to retain most of the cold hardness property even at very high temperature. While machining, the friction between the tool and the tool and the chips causes the heat to be generated, and the tool loses its hardness and its efficiency to cut the finishes. The tool maintains its cutting efficiency even at increased temperature during cutting. It can be said that the possess that red hardness property. Toughness. So, our property of this cutting tool. The property to resist a breakage due to the sudden load that result during the metal cutting in the term as toughness. This will reduce the breakage of the cutting edge of the tool. Following factors are to be considered when selecting tool material: material to be machined, condition of machine tool, total quality of production and the rate of production, dimension accuracy and quality of surface finish, amount of coolant applied and method of application, condition and form of material to be machined. These are different properties of the toughness material. In the last five grouping of the tool material, we have ferrous tool material and non-ferrous tool material and non-metallic tool material. There are three grouping of which tool materials first. Ferrous, non-ferrous, ferrous tool metals, non-ferrous tool metal and non-metallic tool metal. These all are the cutting tool metal. These are the tip type. Ferrous tool metal, these metal have iron as their chief constituent. High carbon steel, tool steel, and high speed steel belong to this group. So ferrous tool metal किती आहे? तीन असं आहे. All iron content cutting tools come under ferrous. For example, high carbon steel, that is in the bracket you can say tool steel. High speed steel. High speed steel even extremely high speed steel. It's costly, but there is iron is present in there. And the cobalt and tungsten mix केला असतं. And the high speed steel केला असतं. Non-ferrous tool material like these do not have iron. They are formed by alloying element like tungsten, vanadium, and molybdenum. इथं बितर non-ferrous metal tungsten घालला, vanadium घालला, molybdenum घालला. Satellite belongs to this group. Stellites belong to this group. Carbide tools, these metals are non-ferrous metals. They are manufactured by powder metallurgy technique. Carbon and tungsten are the chief alloying element. In carbide, all is alloying elements. Remember, they are the powder metal technique. Carbon and tungsten are the chief alloying element. Next, non-metallic tool metals. These tool metals are made of non-metals, that is ceramic and diamonds belong to this group. Diamond and ceramic they are non-metal. They are used as a cutting tool. High carbon steel is the first tool material introduced for the manufacturing cutting tools. It has a poor red hardness property and it loses its cutting efficiency very quickly. So then the alloying element like tungsten, chromium, and vanadium are used to produce high-speed steel. See, the high-speed steel produced from the alloying element like tungsten, chromium, vanadium are used to produce a high-speed steel tool metal. Its red hardness property is more than that of high carbon steel. High-speed steel is used for making solid tools, brace tools, and inserted bit, and it is costlier than the high carbon steel. Carbide cutting tools can retain their hardness very high temperature and their cutting efficiency is higher than that of high speed steel. And the efficiency is very high compared to the high speed steel, but the cost of this metal is very high. Due to its brittleness and cost, the carbide tool cannot be used as a solid tool. It is used as a brace tool and throw away the tool bit. Tool button to the okay, it can be there. Principal element of metal machining. What is the cutting speed? जसे ड्रिलिंग मशीनातून काय कटिंग स्पीड सांगले. Like same way, we have to find the what should be the cutting speed. Okay, what are like drilling machine rotates, know how much RPM is required for the drilling goes. Same way, we should know what is the cutting speed for the turning operation. For the MS solid bar, for the particular diameter, what should be the RPM? It is the speed at which the metal is removed by the tool from the workpiece. So cutting speed, it is the speed at which the metal is removed from the tool, which is removed by the tool from the workpiece. The tool workpiece ला त्याची metal remove करता. This cutting tool, that is the speed. You can see the diagram. We will come to know this is the job workpiece and this is the cutting tool. Speed. This is the speed at which metal is removed by the tool, or metal is removed by this tool from the workpiece. That is the cutting speed. The lathe, just see in the this thing. In a lathe, it is the peripheral speed of the work past the cutting tool expressed in meters per minute. Here also the unit of the speed is meters per minute, and the unit of the speed is same, revolution per mm. For one particular division, how much is going deep low, the revolution per mm is a feet unit. Now here the unit of the speed is speed and feet don't get confused. Okay, speed means rotating speed. Feed means you are giving the depth. In drilling you are doing depth, no, and in the lathe machine you are giving the feed by putting the cutting tool against the rotating depth. It's like 1 mm, 0.1 mm depth. That is the feed. Now see. The equation of the find out the cutting speed is cutting speed V is equal to pi dn upon 1000 meters per minute. Same equation. The same equation we are using for the drilling machine. Okay, to find out the RPM. Same equation you have to remember. V is a cutting peripheral speed that is meters per minute. D is the diameter of the job in millimeter. N is a job or spindle speed. N is a job or spindle speed, that is RPM. The cutting speed, they have already some given for the particular diameter. For 25, what should be the diameter? One RPM 1528. For 50 mm 756. 75 mm 509 spindle RPM. Length of the metal passing cutting tool in the one revolution, that is feed, is also given here, and this is speed. Just remember that equation. Cutting speed V is equal to pi dn upon 1000. You can find the n from that equation. Now, in the case of drilling machine, this RPM problem I solved. No? Similar way, same type of problem will be here also. In the lathe machine, speed calculation. Now, what is the feed? Feed is a feed of the cutting tool in the lathe work is the distance the tool advance for each revolution of the work. एक रोड से कितने भीतर तक कोईता पर देर कोईता, that is your feet. Revolution per mm. The feet is expressed in mm per revolution. This is the unit of this. Feed F may be calculated as follow. Feed F is equal to length upon n multiplied to Tm, where L is equal to length of the cut, and just speed RPM, and Tm machining cutting time. Machining and cutting time. You can find the feed also by using this equation. That F is equal to L upon n multiplied to Tm. L is length of the cut in millimeter, and speed of RPM. Tm is equal to machining per cutting time. It is machining per cutting time, that is minutes. Factors governing feed may be tool geometry, surface finish required on the work, rigidity of the tool, and coolant use. And rate of metal removal, the volume of the metal and the volume of the chip is removed from the 1 minute and is found by multiplying the cutting feed rate and the depth of the cut. See, rate of the metal removal magnet, volume of the metal and volume of the chip is removed. एक तुझे job आपण त्याचं volume and volume of the chip किती तुम्ही chips काढला त्याचे that volume. The volume of the metal and the volume of the chip is removed from the 1 minute, 1 minute is found by multiplying the cutting speed. It has to be multiplied to cutting speed rate, cutting feed rate, and depth of the cut. That is the rate of metal removal. It is feed 0.2 to 1 millimeter per revolution, cutting speed 70 to 100. These are the different metals: aluminum, brass, bronze, cast iron, copper, steel. It should be the feed should be 0.2 to 1 millimeter, and cutting speed should be 35 to 100 meters, 35 to 50 meters per minute. Steel medium carbide, again the speed is same, depth is little bit less, but steel alloy high tensile 0.08 to 0.3, 5 to 10 speed is very less. High tensile. Thermosetting plastic 0.2 to 1 fifth and 35 to 50 is the RPM or cutting speed, that is minute per minute. So these are the speeds if you have to set while doing the